Okay, the next graph we're looking at is the famous parabola, very common to come out, and one of the most difficult graphs in terms of studying because of the different forms that could appear. Okay, so if you look at my slide, you've got the first one, which is the easy one, y equal to ax squared plus bx plus c. That's one form the equation could come out in. Then you have the other one. It's called a square constant form, y equal to a into x minus p all squared plus q. Or you could have a third form, y equal to a into x minus x1 into x minus x2, where x1 and x2 represent your x-intercepts. So you see why this graph creates a little bit of a problem for us. Okay, it's a triangle, which means it's got three sides to its equation, which means we have three different forms that could come out. So if you study only one, you're in trouble. We don't know which one will come out. So if we analyze this a little further, okay, I want to start with the first one. If you want to find a turning point of this graph, how would you find a turning point? Somebody tell me.
So wouldn't you use your equation x is equal to negative 3 plus minus square root of b squared?
Sorry, I can't hear you there, Mr. Wiggle.
So it's minus b over 2a.
All right, in grade 11, your teacher taught you minus b over 2a. But in grade 12, you can use the derivative. If you find the derivative and equate to 0, y prime, you will find the x value. And to find the y value, you will sub it into you'll sub your x value into the equation. So remember, now we have the derivative. If you use x equal to minus b over 2a, that is also correct. Not a problem, all right? Now, if you got a square constant form that you see in here, you do a change of sign on that minus p. Sorry. So your minus p becomes p, and then you use q. So your p and your q represent your turning point. And I'm talking about this. This is the turning point we're talking about if you're confused. The point where the graph turns. And in the last one, you're going to substitute your x-intercepts. And then after you substitute the x-intercepts, you got to bring, using FOIL, bring it back to this form. And then you can find your turning point. Okay, so x-intercept we covered. Let y equal to 0. Y-intercept, we let x equal to 0. Now, to find a domain, this is a standard parabola. If you're looking at a standard parabola, there's no restriction because there's no asymptote. But the range is always y would be greater. In this case, it's greater than and equal to the turning point. So that's when we have a kind of graph. And some of you might say it's a smiling face, you know. When you're in grade 11, we drew a lovely smiling face for you. But if the graph is going the other way, and we basically got a lovely sad face. I said a lovely sad face. That sounds nasty. So when a graph, now you notice the graph is going down. So your range here would be y less than and equal to the y value of the turning point. So remember, it's the y value of the turning point. So that's how you find your domain in the range. But we will practice it now, okay? So you can see today I'm giving you more background before we go into questions. Tomorrow, if you're joining my session tomorrow, I will not be giving background, just cracking with the past papers, all right? So let's go to our first question. So I want you to write this down. F of x equal to minus x squared plus 7x plus 8. That's the equation of the parabola. We also have a straight line, minus 3x plus 24. Let's stop and let's think. If we analyze minus x squared plus 7x plus 8, what does this 8 represent?
The y-intercept.
The y-intercept. So that's point C. Can everyone see that? What does the 24 represent? The y-intercept
of the other graph.
with a straight line. And we can't see it on the graph. It's going to cut somewhere on the top. Okay. So they gave us the equation of the parabola, equation of the straight line. And they say we have the graphs intersecting. So they talk about a point of intersection. How do we find points of intersection?
So we equate the two graphs.
Thank you. We equate both the graphs. Well said. All right. So there's our first question. Determine the coordinates of A and B. Now let's look at the graph. A and B. Those are the x-intercepts. How do we find the x-intercepts of a graph? We let y to be 0. So that's our starting point. That's not the one I want. Something went wrong. Okay. So let's go and find the coordinates of A and B. And we said that what we're going to do, we're going to take minus x squared plus 7x plus 8, and we're going to equate that to 0, because that's how we find A and B, which are our x-intercepts. So I'll give you some time. Can someone work that out? Okay, I worked that out and I got x to be 8 and minus 1. Am I right or wrong?
Right, Zip.
Okay, so now they want us to find A and B. What do you think A is going to be? Will A be 8? A is on the negative side. It has to be minus 1, 0. B is on the positive side. That gives you the 8, 0. Okay, quite an easy question. Agreed? The next one is to calculate the coordinates of D. Now, how do we calculate the coordinates of D?
So it's the intersection of the two graphs, so you have to equate them.
Well done. So it's the intersection of the both graphs, and we equate both. So let's give you some time. Solve for x. Let's give you a minute. We got Samir with us. Samir, do you have an answer?
No, not yet.
Okay. We have a Kubeka with us. Kubeka, do you have an answer?
No, sir.
We got Zachary with us. Zachary, do you have an answer?
No, sir.
Does anyone have an answer?
So it's 8 and 2, sir.
All right, we got one answer. Let's check with mine. Okay, so I brought everything on one side. I skipped some steps. I ended up with x squared minus 10x plus 16, which is equal to 0. Did you guys get this equation after you simplified? X squared minus 10x plus 16 equal to 0. And then I factorized that. I got an x minus 2 into x minus 8 equal to 0. But I'm not going to take the 8. X equal to 8 is point B. So I'm going to take the x equal to 2 because I'm trying to find D. And that's how I end up with x equal to 2. But remember, the question is to find the x coordinate of D. If I wanted to find the actual y value, then all I have to do is substitute 2 at my calculator. If I take this 2 and substitute into the equation called f of x, or even a straight line, I will end up with the b value for d. Okay, this is quite an interesting question. A little higher level question. So it says S is a point on the graph where the x value is between 8 and a. Now we just found a. If you remember the story here, we just found a. And for those of you who are still sleeping, a is actually 2. Okay. So they drew a line for us called ST. That's our line called ST. But it's parallel to the y-axis, which means it's a straight line. It's a vertical line. So the question is to find ST in terms of x. Now, if you want to find a line, straight line between two graphs, what do we do?
The top graph minus the bottom graph, so.
Perfect answer. All right. We take the top graph. Okay. So if we had as an example a point 3732, we'll just say 7 minus 2. What's 7 minus 2? 5. If we had P and Q, P minus Q, we just subtract the Y values. If we had the Y value is A plus 5 and the Y value is that, 3A minus, we just subtract again. And if we look at this graph, the Y value is X plus 5. And a Y value, and to find the line, all you have to do is subtract both. But if you misunderstood everything I said, all we're doing here is we're taking the parabola equation, which is given to us. Can you see that? And we subtract the straight line equation, which is given to us. So basically what we're saying, because they said in terms of x, we don't have values, so we're subtracting both the equations. And if we work that out, we get ST is equal to minus x squared plus 10x minus 16. They didn't say in terms of x, so your answer is going to have x. Any questions? Okay, we go to the next question. The next question is telling us to find a maximum. How do we find a maximum length?
So do we differentiate?
Hey, well done. Let's bring calculus in. If you did calculus with your teacher, he would have told you to find the maximum, find the derivative, and equate to 0. So let's do that. St prime is equal to minus 2x plus 10, and we're going to equate to 0. We get minus 2x to give us minus 10. Dividing by minus 2, we get x to be 5. Are you happy? But that is not the maximum. So to find the maximum, I'm going to take my 5 and substitute it in the ST formula. Can someone do that with the calculator? And that will give me the maximum length of ST.
I got 9, sir.
So he got 9. Perfect. All right. So the maximum length using your calculator is 9 for ST. Okay, so that was a parabola where it was in an ax squared plus bx plus c form. Okay, we can skip all that. That's grade 11, the u squared constant form, okay? Okay, in this question, which is quite famous for a lot of grade 12 papers, we want to just interpret this question first. The question is, for what values of x is f greater than g? So when you're comparing two graphs, greater means above. So if we look at the f graph, and I'm drawing it in blue, that's when it's above. So what is the x value at the first point? It's actually 2. And what is the value where it stops? It's actually 8. So we can write in different notations. My pen, I don't know if the ink is running out. Okay, so I said we got the 2 and we got the 8, and that is our answer in builder notation. Or you could have said x is an element starting at 2 and 8, and a round bracket because it doesn't include. There's no equal to sign with that. Here's our first answer. And all happens if we say greater than equal to, all we have to do is now be a little bit inclusive and change that to a square bracket. Then they want to know when are the graphs equal, and that will be at points of intersection, which we found earlier. They are equal at x equal to the x value at D was 2, and the x value on the other point of intersection is sitting at 8. Okay, so if greater than is above, if they say less than, then we compare both graphs and then look below. Okay. We're going to move on. And you get other points, questions where you're finding the turning point. And we spoke about the turning point now. Find your derivative, equate to 0. Okay. So I'm going to skip that question now because I think we did enough. If you want me to quickly touch on that, how would we find our turning point before I run away? I said find your derivative and equate to. Sorry, find your derivative, equate to 0. And then you substitute. That'll give you the x value. And then you substitute this x value in the equation. If you're looking at a domain, before I run away from this question, x element of reals. And this graph is got a maximum turning point. So we'll say x is less than and equal to the y value of the turning point. Okay, which we would find from the above question. Any question? Okay. So I want to look at this question because it's very different from the first one. So it says, sketched below are the graphs of f of x. They gave us, actually they don't give us because we don't have a, b, c. But they give us g of x is equal to minus x plus 5. What does that 5 tell us again?
The y-intercept.
Y-intercept, all right? So that's the y-intercept 5. Okay. B is the x-intercept. So surely from here we can get out the x-intercept. What will the x-intercept be? So we're going to say y0 minus x plus 5, which gives us x to be 5, okay? So we know this b here is 5. That making sense to you? But the question is, determine the coordinates of b. So for coordinate form, you'll have to write 5, 0. Okay, and then it goes on to tell us a and b, the x-intercepts, and then it gives us point t. Now t is a turning point. B and S are the points of intersection. So the first question was very straightforward. Let's go to the second question. Determine the equation of f in the form. Now, forget about the form. Let's worry about getting the equation. How would we find the equation of this parabola? Talk to me, someone.
So you can put it into the turning point formula.
Well
and
done.
Then use difference, completing the square.
Well done, young man. You see, because they gave us the turning point, we have to use the turning point formula, which is y is equal to a into x minus p all squared plus q. And what we're doing now, we're going to say y is equal to a. There's our turning point. So remember the turning point, we said it represents PQ. So the P value is x minus 3 over 2 all squared. And the Q value is actually 49. Sorry, put that. 49 over 4. Now, we got too many unknowns. Y, A, and X. Our job is to try and find A. Now, X and Y, we can put in a coordinate on the graph. If we have any point in the graph, we can put it in. Is the point given on the graph?
The x-intercept, so
The x-intercept is given. So we see we have a point on the graph, the x-intercept, which is 5, 0. So where you got y, you're going to put 0, which is equal to a. The x value given there is 5 minus 3 over 2 all squared plus 49 over 4. So I'm going to give you a minute now to solve for a. Take your calculators out, work that out, tell me what you get for a.
-1, sir.
So somebody said a is equal to -1. Can we have a confirmation there?
yes, sir.
All right, so we are all getting a to be equal to -1. And now, how is that going to help us out now? So we're going to put this -1 back into that step. So if we do that, we have, remember which step I'm saying? So we got y, I just want some space, sorry. So we're going to have y is actually equal to a, which is -1, into x minus 3 over 2 all squared plus 49 over 4. But if you read the question, they want you to write it in that form. So we means we got to square the binomial. And now we're going to get y is equal to -1. So x minus 3 all squared, square the first term, you got x squared. To get the middle term, first times second, and then double it. So take your calculators out. 1 times -3 over 2 times 2. That should give you minus 3x. And then you square the last term, which gives you that 9 over 4. And then you got a plus 49 over 4. Now we know that a negative sign, -1, distribute into the bracket will change all signs. We'll make it a minus x squared plus 3x minus 9 over 4 plus 49 over 4. And then we can work that out to be minus x squared plus 3x. You can take your calculators out and say, what's minus 9 over 4 plus 49 over 4? It's actually 49 minus 4 is 40. 40 over 4 is 10. And that's how we get it to its normal form. Did anyone get that same answer as me?
Yes, sir.
Well done. We had about 5 or 6 people just leave the session, I think. The numbers are gone down. Anybody knows why? Maybe it's load shedding. Okay, let's move on. So minus x squared plus 3x plus 10, please keep that equation. I might need it when I go to the next slide. Oh, now they're confirming the answer in 5.3. So even if you got it wrong, you can use it. But now they want to find S. How would we find S?
Equate it to gx.
Well done. You got to equate both. We're going to take the G equation was given in the previous question. There's it here. Minus x plus 5. And it's going to be equal. Point of intersection, you equate both. You got a minus x squared plus 3x plus 10. And then we can solve for x. X squared minus comes on that side, becomes a x squared 3, becomes negative, and we got a negative 1, gives us a 4x. 10 becomes negative, that'll give us a minus 5, which is equal to 0. And from there, we can factorize, and we get x to be 5, or x to be minus 1. Now, which one are we going to choose? Remember, b was minus 5. So s will be the point minus 1. And how are we going to find the y value? We can take this and substitute into the equation. And you got minus 1 is a plus 1, so that'll give us 6. So that is our point of intersection. Question. All right, let's move on. Now they want to know from us for 5.1. When is f greater than g of x? So I'm going to draw it for you. There's our, and remember I said greater than means above, but here we got to equal as well. So above and equal. So we're moving from there. Actually, I should change my color. So anyone's got an answer for me?
Negative 1 is less than equal to x, which is less than equal to 5.
Okay, so negative 1 to 5 with a square brackets. And that solves our problem. Okay, because s was found to be minus 1 and the b value was 5. You can write the interval notation. If you write an interval notation, you're going to say x less than or equal to 5, but greater than or equal to minus 1. Okay, let me go to a level 4 question there. Okay, maybe a level 3. We could debate that one. So they want to know from us is when is minus x squared plus 3x minus 2 over 4 less than 0? Anybody wants to give us a starting point?
So is that equation they gave us the actual graph's equation?
This one, okay? We found the actual graph equation to be minus x squared plus 3x plus 10. Let me write that down. So f of x was equal to minus x squared plus 3x plus 10. Closer. So what do we have here? They want to know is when is a minus x squared minus 3x minus, well, 2 times 4 is 8. We can write it as minus 9 over 4 less than 0. Okay, but we got this graph. So I'm going to try and bring this equation to that form. Okay, so I want to bring in a 10. So before I bring in a 10, let's take the 9 over 4 on that side. It's causing a problem for me. Okay, so I took the 9 over 4 that side. And then I'm going to bring in a 10. But if I bring in a 10 on the left, I must bring in a 10 on the right. Are you with me? So that means minus x squared minus 3x plus 10 is less than, now 9 over 4 plus 10 on your calculator, you can use a calculator for that. 9 over 4 plus 10 on a calculator, 49 over
4.
Now, let's investigate. A minus x squared minus 3x plus 10 is actually f of x. If you didn't know that. That's what f of x is. Can you see that? That's the actual graph. When is that less than 49? Sorry. Now, if you look at the graph, what do you notice? Where's 49 over 4?
The turning point.
The turning point. That's the y value of the turning point. All right. So when is this graph that you are seeing? There's the y value of the turning point. When is this graph below that 49 over 4? That's a good question.
So x is or like x is smaller than 3 over 2, or x is an element of the real numbers except for 3 over 2.
Yeah, if you look at the graph, it's always below 49 over 4. I think some of you are missing this important point. Remember now, this y value we're saying is 49 over 4. This graph is always below, except at this point where it's equal. So in other words, we are saying it's always below, except the point where it's equal. Because when it's, the question says only less than. So at the turning point, it's actually equal. And the x value of the turning point is 3 over 2. Sorry, that should be not equal to 3 over 2. So we are saying the graph is always below 49 over 4, except at the turning point, because at the turning point, it's equal to 49 over 4. And that answers that high-level question. That was a good question. Let's move on. Now, we get the third form of the parabola. You know, I told you there's 3 forms. You'll notice the first one I did was a x squared plus bx plus c. The next question was a square constant, a into x minus p. Now we come to the third form. So, if we look at this one, it says the graphs, ax squared plus bx plus c, they gave us a straight line. D minus 1 minus 8 is a common point. We can see that on the graph. Now they tell us f intersects the x-axis, minus 3 and 2. So what do you notice about this graph? The x-intercepts are given. Whenever the x-intercepts are given, the equation you want to use is y is equal to a into x minus x1 into x minus x2. Have you heard of this equation before? Mr. Bingo? You have this equation. Well done. So, but anyway, let's read the question first. 6.1, for which value of x is f of x less than and equal to 0? So if you look at your y-axis, this question wants to know from you, when is the y negative? So that means when is it below? It's negative below the x-axis. Can everyone see that? Below the x-axis, the y is negative. So it's from this point to that point. And then we can answer this question that it starts at minus 3, 2, 2. We have to use a square bracket because we're going to include that. And here's our first answer to that. The second question is determine the values of A, B, C. There's A, B, C. That means find the equation. So to find the equation, you've got to use this as your starting point because the x-intercepts are given. So all I'm going to do is say y is equal to A. First x-intercept is minus 3. X minus minus 3 will give you x plus 3. And the second one, x2, is represented by 2, which is x minus 2. Now remember, what am I trying to do here? I'm actually trying to find A. And remember what I said, if you go to y, x, a, to find A, you sub a point. So we have a point in the graph called xy, which is the D. So D is 1 minus 8, so I'm going to use minus 8 for y. which is equal to a into 1 plus 3. So I'm replacing the x value with 1 and 1 minus 2. Someone can use the calculator quickly to help us out. 1 plus 3
2,
is
sir.
4. 1 minus 2 is minus 1. I just want to check. So we're going to 4 times minus 1 is minus 4a. Divide that and we would get a to be 2. Thank you. Well done. So we got a to be 2. Now, but the question is to find a, b, and c. So we're going to take our a to be 2 and go back to this step and replace the a with 2. So to do that, okay, so remember we got a to be 2. Then we're going to say y is equal to a is 2. We can do FOIL x plus 3 into x minus 2. X squared plus 3x and a minus 2x will give me a plus 1x minus 6. And then we end up with y is equal to 2x squared plus 2x minus 12. And that gives me my a to be 2. Because a is the number in front of x squared, b will be 2. And your c value is minus 12. Any questions? Okay. So the next question is determine the turning point of the graph. So it's 2x squared plus 2x minus 12. So we got y is equal to 2x squared plus 2x minus 12. So I want you to use the derivative method. So we know y prime is equal to 4x plus 2 and equate that to 0. We'll get 4x is equal to minus 2. Divide both sides by 4. We should be getting minus half. So our turning point is actually minus half. And to get my y value, it's very simple. Take this and substitute it in the equation. Can someone do that for us quickly? 2 brackets minus half squared plus 2 bracket minus half minus 12. Somebody?
So I think it's 10.5.
10 and a half, 10.5. Someone to confirm that? Anyone else got 10.5?
Minus 10.5, sir.
Minus 10.5. Are we happy with the answer?
So I got negative 12.5.
Ooh, now we got a problem. We have to check that. See, we can't just take it for granted. Now, I don't know who's right and who's wrong. Can we have a third person to check that?
Sorry, so I got negative 25 over 2.
Yeah, negative 25 over 2 is 12.5.
Oh, yeah, then that's not the same.
Hey, we trust struggling to get the right answer. Who got 10.5? Can you type again?
So I get negative 12, 5, sir.
Yes, sir. Yes, sir. I typed it in wrong. My bad.
Okay, 12.5. You all happy with that? So we use a quick derivative method to find the turning point. And if ever the question is find the axis of symmetry of your parabola, the line that cuts the graph in half, then all you need to know is what is the x value of the turning point. That is the x value. That becomes your axis of symmetry for a parabola. Okay, remember that as well. Okay, then we come to a transformation question. Are you ready? So write down the equation of the axis of symmetry of h if h of x is equal to f of x minus 7 plus 2. A question like this, you always start with the original graph. What is the axis of symmetry of the f graph? And I think we just spoke about that. Remember, if we go back, I told you that the x value of the turning point of the parabola is the axis of symmetry. So we know x is equal to minus half. So we need to know what is happening to this actual graph. So the graph is moving 7 units right. Will we agree with that? And
Yes,
it's
sir.
moving 2 units up. So if we move right, it affects the axis of symmetry. Remember, the axis of symmetry is we're putting on this x value here, which is minus half. So if we move right, it affects it. If we move up, it doesn't affect the axis of symmetry. So we're moving right by 7 units. So that means the axis of symmetry for H would be x is equal to minus half. And we are moving right 7 units. So we're just going to add 7 to that. Pen is running out of ink here again. So x would be equal to, I think, 6.5. Are you happy with that answer?
Yes, sir.
Okay. The last question is to calculate the gradient of G. So this is G, the straight line, and actually that's a tangent. Okay. Now, how do we find the gradient of the tangent? Very simple. If you got the equation, let's get back to the equation. So y is equal to 2x squared plus 2x. What was the minus 12? Now, if we want to find the gradient of the tangent, remember, the derivative is the gradient, okay? So at a point. So if we find the derivative, we'll get 4x plus 2. And the x value there of this tangent to the graph is sitting at x equal to 1. So all we have to do now is substitute the 1. And that means that the gradient for this graph is 6. Any questions? So we've done 3 graphs tonight. We've done the hyperbola, the parabola, and a straight line. How many graphs haven't we done? Nobody knows? Somebody knows? Sorry?
So the exponential.
Okay, so we're missing the exponential and the log graph, which we will do tomorrow night. We'll get into that. Okay, so I don't want to go further in this. I think let's stop there tonight and we will resume tomorrow because we've got an hour on functions.